Hello friends, welcome to my second lecture on Big M method. Here we shall discuss some special cases. Say for example, let us consider the following problem. We shall see that this problem has no feasible solution. So, let us consider the LPP maximize z equal to minus x 1 minus x 2 such that 3 x 1 plus 2 x 2 greater than or equal to 30 minus 2 x 1 plus 3 x 2 less than or equal to minus 30, x 1 plus x 2 less than or equal to 5 and x 1 x 2 are non-negative. Now, what we will do in order to make the right hand side in the second constant positive, here it is minus 30. So, in order to make it positive we multiply this inequality by minus 1 and so this reduces to 2 x 1 minus 3 x 2 greater than or equal to 30. Okay. So, we in order to make this right hand side of the second constant plus positive with positive value we multiplied by minus 1. So, we have multiplying the second constant by minus 1 to make the right hand side positive and adding slack and surplus variables. So, here what we will do, we have here 3 x 1 plus 2 x 2 greater than or equal to 30. So, we add we subtract surplus variable here and here this is 2 x 1 minus 3 x 2 greater than or equal to 30, here also we subtract surplus variable and here we have x 1 plus x 2 less than or equal to 5. So, we add slack variable to convert it into equality and what we will have then maximum of z equal to minus x 1 minus x 2 okay, minus x 1 minus x 2 0 into s 1 0 into s 2 0 into s 3 where s 1 is surplus variable in the first equation in the constant we need surplus variable. So, we take surplus variable as s 1. So, we get 3 x 1 plus 2 x 2 minus s 1 equal to 30 and then in the second constant also we have constant greater than or equal to type. So, we use surplus variable s 2. So, 2 x 1 minus 3 x 2 minus s 2 equal to 30 and third constant is less than or equal to type x 1 plus x 2 less than or equal to 5 we have. So, we use slack variable s 3. So, we have x 1 plus x 2 plus s 3 equal to 5. So, we need 3 variables s 1 s 2 s 3, 2 variables s 1 s 2 are surplus variables and the third variable s 3 is a slack variable. Okay. Now, let us write the corresponding BFS here. So, we have here 1, 2, 3, 4, 5 variables, 5 variables are there okay, and the equations are 3. So, we can take any 2 variables as zeros. So, taking x 1 equal to 0, x 2 equal to 0 okay, but we get s 1 equal to minus 30 and here we get x 2 equal to minus 30 and here we get s 3 equal to 5. So, s 1 s 2 are coming out to be negative, but the variables must all be non-negative in LPP. So, we use 2 artificial variables a 1 and a 2 okay. So, we write the using 2 artificial variables in order to get the initial starting BFS okay. We write the given equations in the following form. So, in order to get a starting BFS we have to add 2 artificial variables a 1 and a 2 in the first 2 constants, because in the third constant when we take x 1 x 2 equal to 0 s 3 is equal to 5. So, we do not have to do this is anything here, s 3 is already non-negative, but in the case of first and second equations s 1 s 2 are coming out to be negative. So, we use artificial variables. So, let us say artificial variables are a 1 and a 2, then we write the LPP in the following form okay. Maximum of z equal to minus x 1 minus x 2 0 s 1 0 s 2 0 s 3 and then we use the negative price vector minus m for the artificial variables. So, minus m a 1 minus m a 2 and here we get 3 x 1 plus 2 x 2 minus s 1 plus 0 s 2 plus 0 s 3 plus a 1 plus 0 a 2 equal to 30. The second equation is 3 x 1 minus 2 x 1 minus 3 x 2 plus 0 s 1 minus s 2 plus 0 s 3 g plus 0 s 1 0 a 1 plus a 2 equal to 30 and then third equation is x 1 plus x 2 0 s 1 0 s 2 then s 3 0 a 1 plus 0 a 2 equal to 5. Okay. Now, we have 1 2 3 4 5 6 7 okay, 7 constants are there and the equations are 3. Okay. So, we take 4 constants, 4 variables as zeros. So, taking x 1 equal to 0, x 2 equal to 0, s 1 equal to 0, s 2 equal to 0. Taking x 1 equal to 0, x 2 equal to 0, s 1 equal to 0, s 2 equal to 0, the first equation gives us a 1 equal to 30. Okay. So, a 1 equal to 30. Second equation gives us what? We get from the second equation x 1 x 2 0, s 1 s 2 0, and we get a 2 equal to 30. Okay. So, we get a 2 equal to 30, and third equation gives x 1 x 2 0, s 1 s 2 0. So, we get s 3 equal to 5. So, we get s 3 equal to 5. So, thus we see that x 1 x 2, s 1 s 2, s 3, a 1 a 2 are all non-negative, and therefore, it can be taken as a starting basic feasible solution. Now, let us consider first simplex table. So, Cj's are coefficients of the variables in the objective function. So, coefficient of x 1 is -1, coefficient of x 2 is -1, coefficient of s 1 is 0, coefficient of s 2 is 0, coefficient of s 3 is 0, coefficient of a 1 is -m, coefficient of a 2 is -m. Okay. Basis vectors are a 1, a 2, s 3, and the non-basic variables are, basic variables are a 1, a 2, a 3. These are a 1, a 2, a 3, a 1, a 2, a 3. These are basic variables, and non-basic variables are x 1, x 2, s 1, s 2, s 3. Okay. X 1, x 2, s 1, s 2. Okay. X 1, x 2, s 1, s 2. They are non-basic variables. These are non-basic variables. Okay. Now, we this in the initial simplex table, the x 1 column contains the coefficient of x 1 here. So, coefficient of x 1 are 3, 2, 1. Okay. We get 3, 2, 1 here. Coefficient of x 2 are 2 minus 3, 1. So, we get 2 minus 3, 1 here. Coefficient of s 1 is minus 1, 0, 0. Okay. We get minus 1, 0, 0. Coefficient of s 2 is 0, minus 1, 0. So, we get 0, minus 1, 0. Coefficient of s 3 is 0, 0, 1. Okay. We get 0, 0, 1, and then coefficient of a 1 is 1, 0, 0. Coefficient of a 2 is 0, 1, 0. Okay. So, we get this, and B column is the right hand side of these constants. So, 30, 35. Okay. That is B column. Okay. Now, the coefficient of a 1 in the objective function is minus m, coefficient of a 2 in the objective function is minus m, and coefficient of s 3 is 0. So, CB column contains the coefficients of the basic variables in the objective function. Now, we then find zj star, zj star equal to sigma CB aij. So, we multiply CB column to the column x 1 and get z 1 star. This is j equal to 1, this first column. So, j equal to 1. So, z 1 star will be minus 3 m minus 2 m, and 0 into 1 is 0. So, we get total minus 5 m. Okay. And Cj is small, capital Cj is small cj minus zj star. So, from this Cj value we subtract zj star, and we what we get is 5 m minus 1. Similarly, we can find in zj star for the second column. So, we get minus m into 2 minus 2 m, minus m into minus 3 is 3 m, 3 m minus 2 m is m. Okay. 0 into 1 is 0. So, zj star is m. So, then C2, capital C2 is small c 2 minus z 2 star. So, minus 1 minus m. So, we get minus m minus 1. Similarly, in the column corresponding to S 1, it comes out we get z 3 star equal to m, and therefore, capital C 3 is 0 minus m. So, we get minus m here. In the column S 2, zj star, which is z 4, j equal to 4, z 4 star is m, and so C 4, capital C 4 is minus m, and in the C S 3 column zj star, j equal to 5 is 0, and so 0 minus 0 is 0, C 5 is 0, and in the column for A 1 we get zj star equal to minus m. So, minus m minus m becomes 0, and here for A 2 also zj star is minus m. So, minus m minus m is equal to 0. So, we get this. Now, so 5 m minus 1. Okay. This is a positive value, this is negative, this is negative, this is negative. Okay. So, C j is greater than 0 for j equal to 1. Okay. So, this is key column, this is key column. let us find key row. Okay. So, divide the elements in the B column, okay, by the corresponding elements in the x 1 column. So, 30 by 3 gives you 10, then 30 by 2 gives you 15, then 5 divided by 1 gives you 5. So, we get 5. Okay. Now, we have to find the minimum positive ratio here. So, clearly 5 is the minimum positive ratio. So, this is key row. Now, key row, at the intersection of key row and the key column, we get the key element. So, this is our key element. Key element is 1. Now, with the so that means that S 3 will be outgoing variable, okay, and x 1 will be incoming variable. So, in the next simplex table, basis vectors will be the basic variables will be a 1, a 2, s 1, s 3 will be replaced by x 1. Okay. Coefficient of a 1 is minus m in the objective function. So, minus m here, coefficient of a 2 is minus m here, coefficient of x 1 is minus 1. So, we put minus 1 here, and then we have x 1, x 2, s 1, s 2, s 3, a 1, a 2, b. Okay. Now, the key element is 1. If it is not 1, we will divide it so that it becomes 1, but it is already 1. Okay. So, what we will do with the help of this key row, we will be making the other elements in the x 1 column 0, that is 3 and 2 we have to make 0. So, let us first write this key row. We have 1, 1, 0, 0, 1, 0, 0. Okay. And we have 5 here. Okay. Now, we multiply by 3 this key row and subtract from this first row, this row. So, we get 0 there, okay, and we multiply it by 3. So, 3 we subtract from 2, we get minus 1, and 3 we multiply to 0 and subtract from minus 1. So, it remains minus 1. 3 into 0 is 0, with 0 minus 0 is 0, then 3 into 1 is 3. So, we get minus 3 there, and then we get 3 into 0 is 0. So, we get 1 here, 3 into 0 is 0. So, we get 0 here. Okay. We are multiplying by 3 and subtracting. So, 5 into 3 is 15, 15 when we subtract from 30 we get 15. Okay. Now, second row, we multiply this row by 2 and subtract from this row. So, we get 0 here. Okay. We are multiplying this row by 2 and subtracting from here. So, 2 minus 2 is 0. Then we multiply by 2 and subtract from here. So, minus 3 minus 2 is minus 5. Okay. Then we are multiplying by 2 and subtracting. So, 2 into 0 is 0, 0 minus 0 is 0. Then we 2 into 0 is 0. So, it remains minus 1. 2 into 1 is 2. So, we are subtracting. So, minus 2 there. Okay. And then we 2 into 0 is 0. So, it remains 0. 2 into 0 is 0. So, it remains 1, and then 2 into 5 is 10. 10 when we subtract from 30 we get 20. Okay. So, this is the next simplex table. We can see CB is minus m minus 1 in the CBA column. In the basis we have a 1 a 2 a 1 a 2 x 1. We can see a 1 a 2 x 1. X 1 column is 0 0 1. X 1 column is 0 0 1, x 2 column is minus 1 minus 5 1, minus 1 minus 5 1, s 3 column is x 1 column is minus 1 0 0, we get minus 1 0 0, s 2 column is 0 minus 1 0, 0 minus 1 0, s 3 column minus 3 minus 2 1, this is minus 3 minus 2 1. Okay. A 1 column is 1 0 0, 1 0 0, A 2 column 0 1 0. So, we get 1 0 0, 1 0 1 0, and B column is 15 20 15 25. Okay. So, we get 15 25. All right. Now, we can find Z j star. So, minus m into 0 0 minus m into 0 0 minus 1 into 1 is minus 1. So, we get minus 1. Minus 1 when we subtract from minus 1 we get 0, and here we get minus m into minus 1. So, plus m minus m into minus 5 m. So, plus 5 m, 5 m and m becomes 6 m, 6 m minus 1 we get. So, when we subtract 6m minus 1 from minus 1 we get minus 6m. Okay. And then similarly, in the S1 column Zj star becomes m, S2 column Zj star becomes m, S3 column Zj star becomes 5m minus 1, in the A1 column it is minus m, A2 column it is minus m. Okay. And the corresponding capital Cj values are minus m, minus 5m, 0, 0. Now, you can see that all Cj values are less than or equal to 0. This is 0, this is minus 6m. So, less than or equal to 0, less than or. So, all Cj values are less than or equal to 0. So, what we have here, no Cj is positive, hence the optimality condition is satisfied, and therefore, this solution is optimal. Okay. And so, x1 is equal to 5, we can see x1 is equal to 5, okay. x2 equal to 0, S1 equal to 0, S2 equal to 0, S3 equal to 0, and A1 equal to 15, A1 equal to 15, A2 equal to 20. Okay. Now, so artificial vectors A1, A2 appear in the basis at positive level, we can see A1, A2 occur at positive level, okay. Their B values are positive. So, they occur at the positive level, which indicates that the given problem has no feasible solution. Okay. Now, let us go to problem 2. Consider the following LPP. Here we will have unbounded solution. So, maximum of Z we have to find. Z is 3 x1 plus 2 x2 plus x3, and we are given the constants minus 3 x1 plus 2 x2 plus 2 x3 equal to 8, minus 3 x1 plus 4 x2 plus x3 equal to 7. x1, x2, x3 are non-negative. So, we will use to select two artificial variables A1, A2 to convert this form to the standard form. So, Z equal to 3 x1 plus 2 x2 plus x3 minus ma1 minus ma2, okay. And we have minus 3 x1 plus 2 x2 plus 2 x3, and then we have a1 plus 0 a2 equal to 8, okay. And minus 3 x1 plus 4 x2 plus x3 0 a1 plus a2 equal to 7, okay. So, x1 x2 x3 greater than or and a1 a2 greater than or equal to 0. Now, we have 2 equations and 5 constants, 5 variables, okay, x1 x2 x3 a1 a2. So, we take any 3 variables equal to 0. So, let us take the variables x1 x2 x3 equal to 0 each, okay. We get the value of a1 as 8 and the value of a2 as 7. So, this is our starting BFS, okay. x1 equal to 0, x2 equal to 0, x3 equal to 0, a1 equal to 8, a2 equal to 7. This is our starting basic feasible solution. Now, let us write the first simplex table. So, Cj, the coefficients of x1, x2, x3, a1, a2, they are given here 3, 2, 1 minus m minus m, okay. x1, x2, x3 are our non-basic variables, a1, a2 are basic variables. So, a1, a2 occur here, their coefficient in the objective function are minus m each. So, we put them they here, and the coefficients in the x1 column the coefficients are minus 3 minus 3. In the x2 column we have 2 4. So, minus 3 minus 3 2 4, and then we get x3 column coefficients are 2 1, okay. So, 2 1 here, a1 coefficient is 1, here it is 0. So, 1 0, and then a2 column has 0 1, okay. So, 1 0 0 1, and b column is the equations the right hand side of the equations at 8 and 7. So, we get 8 and 7 here. Now, we can find Zj star. We can find Zj star. So, Zj star is equal to for j equal to 1. So, minus m into minus 3 3m, this is 3m, 3m plus 3m is 6m. So, 3 minus 6m is here, okay. Similarly, for the x2 column minus 2m minus 4m. So, minus 6m we get 6m plus 2, that is C2, okay, capital C2. Now, minus m into 2 minus 2m minus m into 1 minus m. So, we get minus 3m, and then C3 capital C3 is 3m plus 1, and similarly C4 is 0, C5 is 0. Now, we can see Cj is positive in the second column and Cj is positive in the third column, okay. But 6m plus 2 is greater than 3m plus 1, okay. So, this is our key column. Okay. Divide the elements of the B column by the corresponding values in the key column. So, 8 by 2 is 4 and 7 by 4 is here. Okay, for this 7 divided by 4 we get 7 by 4. So, out of this 4 and 7 by 4, 7 by 4 is clearly minimum. So, this is our key row. Okay. At the intersection of key row and the key column we get 4. So, key element is 4. Okay. Now, so this means what, A2 will be outgoing variable, X2 will be incoming variable, and okay. So, we have CB basis, in basis we get basic variables as A1, X2 will be replaced by A2 will be replaced by X2, coefficient of A1 is minus m, coefficient of X2 is 2, okay. And we get then X1, X2, X3, A2 column will be deleted in the next simplex table, X1, X2, X3, A1, and then we have B. So, okay. Now, what we will divide, what we will do, we will divide by key element all the elements of the key row. Okay. So, we get minus 3 by 4, okay. 1, we get 1 by 4, we get 0, we get 7 by 4. Now, having made this key element 1 unity, okay, we then subtract suitable multiples of this from the other rows to make the other entries in the key column zeros. Okay. So, we have to make this 2 0, okay. That means, we multiplied by 2 and subtract from the first row. So, what we will get when you multiply it by 2, it becomes minus 3 by 2. So, minus 3 by 2 we have to subtract from minus 3. So, we get minus 3 plus 3 by 2, okay. And then we are multiplying it by 2, okay, and subtracting from here. So, we get 0 here, we are multiplying it by 2. So, 1 by 2 we subtract from 2. So, 2 minus 1 by 2, and then we are multiplying it by 2 and subtracting from the first row. So, we get 1 here, and we are multiplying it by 2. So, 7 by 2 we have to subtract from 8. So, 8 minus 7 by 2. So, what we will have, this is minus 3 plus 3 by 2, it is minus 3 by 2, okay. And here we get 2 minus half, that is 3 by 2, and here we get 16 minus 7, so 9 by 2. So, let us see in the new simplex table, we should have these values, okay. So, CB column you can see contains CB column is minus M2, okay, minus M2. Basis variables are A1, X2. So, you can see A1, X2. X1 column we have minus 3 by 2 minus 3 by 4. So, minus 3 by 2 minus 3 by 4, X2 column 0 1, X3 column 3 by 2 1 by 4, 3 by 2 1 by 4, A1 column 1 0, and B column is 9 by 2 7 by 4. So, we get 9 by 2 and 7 by 4. Okay. Now, we go to determining the values of ZJ star for each j. Okay. So, you can see here minus m into minus 3 by 2 is 3 by 2 3 m by 2, and this is 2 times minus 3 by 2. So, minus 3 by 2. Okay. So, total is 3 m by 2 minus 3 by 2, and when we subtract this value from 3 we get minus 3 m plus 9 by 2. Okay. And similarly, in this for j equal to 1, for j equal to 2 we get C2 small c2 is 2 and Z2 star is 2, because minus m into 0 is 0, 2 into 1 is 2. So, we get 0 here. C3 capital C3 is 3 m plus 1 by 2 and capital C4 is 0. Now, clearly 3 m plus 1 by 2 is positive. Okay. So, this is our key column. Okay. Now, let us find key row. So, divide the B column values by the column values of x3. So, 9 by 2 divided by 3 by 2. So, we get 3. Okay. 7 by 4 divided by 1 by 4 gives you 7. So, minimum positive ratio is 3. So, this is our key row. Okay. So, this key element is 3 by 2. Now, we have to after we have allocated the key element, which variable will be going out? A1 will be outgoing variable, okay, and x3 will be incoming variable. So, in the new simplex table we will have CB column, the basis will have vector the variables x A1 will be replaced by x3, okay. So, x3 x2, coefficient of x3 is 1, coefficient of x2 is 2, okay, and x1 x2 x3. A1 will also be going out. So, A1 column will be deleted, and so we have x1 x2 x3 and b, okay. Now, we divide the key row by 3 by 2 by the key element, okay. So, dividing by 3 by 2 it becomes minus 1 0 1 and 1 over 3 by 2 means though this A1 column is not there, 3 by 2 be 9 by 2 divided by 3 by 2 gives you 3, okay. And then after we have made this element key element 1, we have to make the element 1 by 4 0, okay. So, we multiply it by 1 by 4 and subtract from second row. So, this becomes 0 and we are multiplying by 1 by 4 subtracting from second row. So, minus 3 by 4 and plus 1 by 4. So, minus 2 by 4. So, we get minus half and then we multiply it by 1 by 4 subtract from here. So, this remains 1, okay. We multiply it by 1 by 4. So, we get 3 by 4, 3 by 4 we subtract from 4 7 by 4 and we get 1, okay. So, let us see in the new simplex table we have CB 1 2, CB column 1 2, basis column has x3 x2. So, x3 x2, x1 column has minus 1 minus half. So, minus 1 minus half, x2 column 0 1 0 1, x3 column 1 0 1 0, x4 column 3 1. So, 3 1, okay. So, we get 3 1 here. Now, let us find ZJ star. So, 1 into minus 1, 2 into minus half minus 1 minus 1 minus 1 minus 2, okay. 3 minus minus 2 is 5, okay. And here we get 1 into 0 0, 2 into 1 2. So, we get 2 2 minus 2 is 0 and then 1 into 1 is 1, 2 into 0 0. So, 1 we subtract from 1, okay. So, we get 0 here, okay. ZJ star is 1, okay. And then what we notice Cj is positive in for j equal to 1. So, this is our key column, okay. So, x1 is incoming vector, x1 is incoming vector, okay, but we cannot select the outgoing vector because x1 column has all elements negative, all the elements of the x1 column are negative, which is the incoming vector. Thus, we cannot select the outgoing vector, because to select the outgoing vector we find the minimum positive ratio, and what we will have here this key column. So, we divide the elements of B column by the elements of key column. So, 3 divided by minus 1 this will be minus 3, 1 divided by minus half will be minus 2, okay. So, no positive ratio is there, theta is negative in the first row as well as in the second row. So, we cannot find the outgoing vector and therefore, the solution is unbounded. Now, let us consider the case where the problem contains constant term in the objective function. So, in a LPP when the objective function contains a constant term, then the simplex method is applied by leaving this constant term in the beginning and optimal solution is obtained. In the end, the constant term which was left initially is added to the optimal value of the objective function. So, let us say we have to maximize 2 x 1 minus x 2 plus x 3 plus 50, then with subject to the constants 2 x 1 plus 2 x 2 minus 6 x 3 less than or equal to 16, 12 x 1 minus 3 x 2 plus 3 x 3 greater than or equal to 6, minus 2 x 1 minus 3 x 2 plus x 3 less than or equal to 5, x 1 x 2 x 3 non negative. Then what we will do, we will consider the corresponding problem where we will drop this 50. We will simply consider the objective function 2 x 1 minus x 2 plus x 3 with these constants and find the optimal solution, and in the optimal value of z we will add 50. So, let us see, we have leaving the constant term 50 from the objective function in the beginning, introducing slack, surplus and artificial variables. The given problem reduces to maximum of z dash. We will call the new z as z dash because we are dropping 50. So, maximum of z dash 2 x 1 minus x 2 plus x 3. Okay. We have 2 x 1 minus x 2 plus x 3, and then you see first equation is first constant is 2 x 1 plus 2 x 2 minus 6 x 3 less than or equal to 16. So, we use a slack variable s 1 here. Okay. So, 2 x 1 plus 2 x 2 minus 6 x 3, okay, plus s 1 is a slack variable equal to 16. Second equation is greater than or equal to type. So, we use a surplus variable. So, 12 x 1 minus 3 x 2 plus 3 x 3, okay, minus s 2, and then we will have to add a artificial variable a1 in order to get the starting VFS. So, artificial variable a1 be add and we give a large penalty minus m to this. So, minus m a1, okay. And then third equation is minus 2 x 1 minus 3 x 2 plus x 3, we use a slack variable here s 3, okay. So, minus 2 x 1 minus 3 x 2 plus x 3 plus s 3 equal to 4. Now, let us take x 1 x 2 x 3 s 1 s 2, where x 1 x 2 x 3 s 1 s 2 s 3 a 1 are all non negative. We have 3 equations here, okay, and we have 7 variables, okay, 7 variables. So, we take 4 variables as zeros, okay. So, x 1 equal to 0, x 2 equal to 0, x 3 equal to 0 and s 2 equal to 0, okay. Because if you instead of s 2 you take a 1 equal to 0, we will get s 2 equal to minus 6, okay. So, x 1 equal to 0, x 2 equal to 0, x 3 equal to 0, s 2 equal to 0 we take, okay. Then what we will get, s 1 will come out to be 16, a 1 will be 6, and then s 3 will be equal to 4. So, x 1 x 2 x 3 s 1 s 2 s 3 and a 1 a all are non negative, okay, a 1 are all non negative. So, we get the starting basic feasible solution, okay. The solution of the problem by simplex method is given in the the following table. So, Cj we have Cj 2 minus 1 1, okay, 2 minus 1 1 0 0 0 minus m 0 0 0 minus m. Basis vectors are s 1 a 1 basic variables are s 1 a 1 s 3, s 1 a 1 s 3, they are basic variables, okay. Non basic variables are x 1 x 2 x 3, okay, x 1 x 2 x 3 and s 2, okay, they are non basic variables. And the coefficients of s 1 a 1 s 3 in the objective function are 0, minus m and 0, okay. In the x 1 column we get 2 12 minus 2, 2 12 minus 2, x 2 column has coefficients of x 2 in the constants. So, 2 minus 3, 2 minus 3 minus 3, x 3 column minus 6 3 1, minus 6 3 1, s 1 column 1, there is no s 1 here. So, 0 1 0, there is no s 1 here. So, 1 0 0, okay. So, 1 0 0, s 2 column 0 minus 1 0, okay. So, 0 0 minus 1 0, s 3 column 0 0 1, okay. So, we get 0 0 0 1, okay. A 1 column 0 1 and then we get 0. So, 0 1 0, okay. X b column 16 6 4. So, we get 16 6 4. Now, we can find z j star for j equal to 1. So, 0 into 2 is 0, minus m into 12 is minus 12 m and 0 into minus 2 is 0. So, we get minus 12 here, 12 m here. We subtract this z 1 star from C 1. So, 2 plus 12 m we get. Similarly, C 2, capital C 2 comes out to be minus 1 minus 3 m, and C 3 comes out to be 1 plus 3 m, and then it is 0, this is 0 minus m. So, minus m here, 0 minus 0 0 here, and then we get minus m minus m, that is minus m plus m, that is 0, okay. Now, we can see the, m is very large. So, 2 plus 12 m is the maximum C j, which is positive. Of course, C j is positive in this column also, and so C j is positive for j equal to 3 and j equal to 1, but C 1 value is more than C 3 value. So, we will this is our key column. Okay. So, this means that x 1 will be incoming variable. Let us now find outgoing variable. So, divide the elements of B column by the elements of key column. So, 16 divided by 2 is 8, 6 divided by 12 is half, okay, this is half, and then 4 divided by minus 2 is minus 2. So, we have to consider minimum positive ratio. Minimum positive ratio is this half. Okay. So, this is our key element, intersection of key row and key column gives us the key element. So, key element is 12. Okay. Now, so this means A 1 will be outgoing variable, x 1 is incoming variable, and A 1 is outgoing variable. And in the next simplex table, A 1 will not be there, the A 1 column will not be there. Okay. What we do now? So, new simplex table will be C B, okay, 0 minus A 1 is going out, A 1 is replaced by x 1. So, okay. So, basis, so S 1, A 1 is replaced by x 1, coefficient of x 1 is 2 here, okay, and then we have S 3. S 3 coefficient is 0 here, okay, and we get x 1 x 1. So, x 1 is now divide the elements of key row, okay, by the key element. So, this means when you divide the key row by 12, the key element 12, then what it will get 1 minus 3 by 12. So, minus 1 by 4, and then 3 by 12. So, 1 by 4, and then we get 0, and then we get minus 1 by 12, okay, this is minus 1 by 12, and then this is 0, okay. A 1 column will not be there in the new simplex table. So, 6 divided by 12, so that is half, okay. This is the x 1, x 2, x 3, okay, x 1, x 2, x 3, and then we get S 1, S 1, S 2, okay, and then we get S 3, and we get here B vector, okay, B column. So, now we will make with the help of this key element change to 1, we will make this 0, okay, first row in the this element 2 0 in the column corresponding to x 1. So, we multiplied by 2, subtract from there. So, we get 0 here, we multiplied by 2, we get minus half, we subtract from there. So, we get 2 plus half. So, 5 by 2, and we get multiply by 2, we get 1 by 2, 1 by 2 we subtract from minus 6. So, we get minus 13 by 2. So, we get here my x in the x 3 column we get minus 13 by 2, okay. And then S 1 column, okay, we are multiplying by 2, okay, after dividing by 12. So, we are to come here, okay. So, so this will remain 1, this will remain 1, we multiplied by 2, we get minus 1 by 6, which we subtract from this 0. So, we get 1 by 6 here, okay. And then we get in the S 3 column we have 0 here, we multiplied by 2, subtract from 0, we get 0 here, we multiplied by 2, we get 1, we subtract from 16, we get 15, okay. And then this minus 2 also has to be made 0. So, we multiplied by 2, okay, we multiplied by 2 and added to the third row. So, this becomes 0, we multiplied by 2. So, we get minus half we add to minus 3, okay. So, minus 3 minus half, we get minus 7 by 2. So, we get minus 7 by 2, and we will have to now go to x 3. X 3 means we are multiplying by 2 and adding, okay, adding to this row, okay. So, here we have 1, here we have what 1 by 4. So, 1 by 4 we multiply by 2, 1 by 2 we get 1 by 2 we add to 1 we get 3 by 2, okay. 1 we multiply here by 2, this is 0, we multiply by 2. So, we get 0, 0 we add to 0 and we get 0 here. Then we multiplied by 2 here, we get minus 1 by 6, minus 1 by 6 we add to 0, we get minus 1 by 6 here, and in the S3 column we have 0, we multiplied by 2 and add 2 G1. So, we get 1 here, and here we get 1 by 2, we multiply by 2, we get 1, 1 we add to 4, we get 5. Okay. So, let us see in the new simplex table, CV column has 0 to 0. So, we get 0 to 0, S1 column basis variables are S1, X1, S3. So, S1, X1, S3. Okay. Then the X1 column has 0, 1, 0 values. So, we get 0, 1, 0 values. X2 column 5 by 2 minus 1 by 4 minus 7 by 2. Okay. So, we see 5 by 2 minus 1 by 4 minus 7 by 2. Okay. So, we match this X2 column elements, and then X3 column minus 13 by 2 1 by 4 minus 13 by 2 1 by 4 and then 3 by 2. Okay. This, and then S1 column 1 0 0, we get 1 0 0, S2 column 1 by 6 minus 1 by 12, okay, and minus 1 by 6. So, they also match, and then 0 0 1 in the S3 column. Okay. B column has 15, 1 by 12, this should be 6 divided by 12, this should be 1 by 2. Okay. So, here 1 by 2 it should be, this should be 1 by 2. Okay. Now, all right, and then the okay. So, and this one is 5, this one is 5. Okay. So, they match now. Now, we can see we find Z star is 2 minus half 0 minus 1 0, okay, and C j values are then 2 minus 2 0. So, 0 minus half 0 1 by 6 0. There are two positive values 1 by 6 1 by 2 of the capital C j. So, 1 by 2 is greater than in the 2. So, this is our key column. Okay. Now, let us, so this means X3 is incoming variable. So, X3 is incoming variable. Let us find the outgoing variable. So, we divide the elements of the B column by the values in the column X3. So, 15 divided by minus 13 by 2. So, we get a negative value of theta, and then 1 by 2 divided by 1 by 4. Okay. So, 1 by 2 divided by 1 by 4 is equal to 4 by 2, we get 2. So, we get 2 here. Okay. And here what we get 5 divided by 3 by 2. So, we get 10 by 3. So, there are two positive values of theta 2 and 13, 10 by 3. So, 2 is minimum. So, this is our key row, and then at the intersection of key row and the key column we get the element 1 by 4. So, key element is 1 by 4. Okay, 1 by 4. Now, we divide. So, this means what will happen, X3 is incoming variable, X1 is outgoing variable. Okay. So, now the CB column will be having 0 basis variables will be S1, X1 will be replaced by X3, and we will have S3. X3 coefficient is 1, S3 coefficient is 0, okay, and we have X1, X2, X3, S1, S2, S3 and B. Okay. The elements of the key row are divided by key element. So, we divide by 1 by 4. So, this 1 is divided by 1 by 4, we get 4. Okay. So, we get 4 here. 1 minus 1 by 4 divided by 1 by 4 gives you minus 1. This is 1 and this is 0 divided by 1 by 4 is 0. Minus 1 by 12 divided by 1 by 4. So, 4 by minus 1 by 12 divided by 1 by 4. So, we get minus 1 by 3. So, we get here minus 1 by 3 and we get 0 divided by 1 by 4 is 0, and we divide 1 by 2 divided by 1 by 4. So, we get 2 here. Okay. Now, we have made this element 1. Okay. With the help of this 1, we make the elements of the element minus 13 by 2 0. Okay. So, we multiplied by 13 by 2, okay, and add to the elements of the first row. So, 13 by 2, 4 into 13 by 2 gives you 26. Okay. So, 13 by 2 we are multiplying to 1 in order to make this 0. 13 by 2 we are multiplying, 13 by 2 into 4 is 26. So, 26 we add to this one 0. So, we get 26. Then we have minus 1 into 13 by 2. So, minus 13 by 2 minus 13 by 2 we add to 5 by 2. So, minus 8 by 2. So, we get minus 4. So, we get minus 4 here, x 3 this is 0. Okay. Then we multiplied by 13 by 2 and add to the first row, right. So, S 1 here it is 0. When we multiply with 13 by 2, this will remain 1. Okay. Minus 1 by 3 we multiply by 13 by 2. So, minus 1 by 3 into 13 by 2. So, what we get is minus 13 by 6. So, minus 13 by 6 we add to 1 by 6. So, 1 by 6 minus 13 by 6 and we get minus 12 by 6 which is minus 2. Okay. So, we get minus 2 here and then here what we will have 0 when we multiply by 13 by 2 and add to 0 it will remain 0. We multiply 2 by 13 by 2. So, 2 into 13 by 2 means 13. So, 13 we add to 15 and we get 28. Let us see whether these values match. Okay. So, 26 minus 4 0, 26 minus 4 0, 1 minus 2 0, 1 minus 2 0, 28. So, 1 minus 2 0, 28 and then second row is 4 minus 1 1. So, 4 minus 1 1, 0 minus 1 by 3, 0 minus 1 by 3 0 2, 0 minus 1 by 3 0 2. Okay. So, here we have 4 divided by 13 by 2. So, 4 divided by 3 by 2. Okay. This is to be made 0. So, 4 into 3 by 2 is 6. Okay. So, 6 we subtract from 0 and we get minus 6 here. Okay. And then what we have minus 1 into 3 by 2. So, we get minus 3 by 2, minus 3 by 2 we subtract from minus 7 by 2. So, minus 7 by 2 plus 3 by 2 and we get here minus 4 divided by 2, we get minus 2. This is 0. Okay. And then we are multiplying by 3 by 2. So, 0 into 3 by 2 is 0. Okay. We subtract that from 0. Okay. So, we get 0 here and here what we have minus 1 by 3 we multiply by 3 by 2. So, we get minus half we subtract from minus 1 by 6. So, minus 1 by 6 plus half and this is equal to what 6 minus 1 plus 3. So, we get 2 by 6 and that gives you 1 by 3. So, we get 1 by 3 here. Okay. Then in the S3 column the element is 0 we multiplied by 3 by 2. So, it becomes 0 subtracted from 1. So, we get 1 here and then 3 by 2 into 1 by 2, 3 by 2 oh no it is 2 now, 3 by 2 into 2 is 3. So, 3 we subtract from 5 and we get 2 here. So, let us see this row sigma in the next table. So, minus 6 minus 2 0 0 minus 6 minus 2 0 0 1 by 3 1 2 1 by 3 1 2. Okay. So, now we have found ZJ star here and the corresponding Cj values. So, Cj values are now minus 2 0 okay, 0 0 1 by 3 0. So, there is still one Cj value which is positive. Okay. So, this is our key column. So, so that means S2 will be incoming vector, incoming variable. incoming variable. Now, let us find outgoing variable. Okay. So, we divide the b values, okay, by the key column values. So, 28 divided by minus 2, that is minus 14. So, it is a negative value, and then 2 divided by minus 1 by 3. So, what we get is minus 6. So, that is also negative. Then 2 divided by 1 by 3. So, that is 6. Okay. So, this minimum positive ratio is this. So, this is our key row and this is key element. So, key element is 1 by 3. Okay. This means that S 3 will be outgoing variable. Okay. So, we will have now C B column as basis. So, basis will be having variables S 1, okay, and x 3. S 3 will be going out. In place of S 3 we shall have S 2. Okay. Yeah. S 1 coefficient is 0, x 3 coefficient is 1, S 2 coefficient is 0. Okay. We will have x 1, x 2, x 3, S 1, S 2, S 3 and B. Okay. Now, we divide the elements of the key row by key element. So, we divide by 1 by 3. Okay. So, dividing by 1 by 3 means minus 6 into 3, that is minus 18. So, it will become minus 18. Okay. And then minus 2 divided by 1 by 3 we will get minus 6, then 0 here, 0 here, okay, and this will become 1 here. Okay. 1 divided by 1 by 3 gives you 3, and then 6 divided by 1 by 3 gives you 18. Okay. And then we can make with the help of this one, we can with the help of this one we can make the other entries in the S 2 column zeros. So, this minus 2 and minus 1 by 3 they have to be made zeros. Okay. So, we multiply this new row new key row by 2 and add 2 minus 2 there. Okay. So, that it becomes 0. Okay. The new row we will have here, and then be multiplied by 1 by 3 and add to this second row. So, that this minus 1 by 3 becomes 0. So, after that we get the following table. So, we see S 1 x 3 S 2 we have S 1 x 3 S 2 we have 0 1 0, they are the values in the C B column. Okay. C B column, and this is third row we have written here minus 18 minus 6 0 0 1. So, minus 18 minus 6 0 0 1, and then we have 3 6 3, and we have this 2 becomes 6, no, not 18, 6. Okay. So, we get match, they are matching. Now, we can make these elements minus 2 and minus 1 by 3 0 by multiplying this row suitably and adding. Okay. And so, we will get the following table. Okay. This table we have, and in this table we have found the values of Z j star, the corresponding values of C j. C j is 4, 2, 0, 0, 0, minus 1. So, there are 2 positive values, but the value 4 is the maximum. So, this is our key column. Okay. So, that means x 1 is incoming variable. Let us find outgoing variable, but we notice that all the values in the x 1 column are negative. Okay. Minus 10, minus 2, minus 18. Okay. So, to get the outgoing vector, what we have to do is we have divide the elements in the V column by the corresponding elements in key column. So, this is minus 40 divided by minus 10. So, that will be minus 4 here, 4 divided by minus 2 will be minus 2 here, 6 divided by minus 18 will be minus 1 by 3 here. So, there is no positive ratio. Okay. And therefore, we cannot find the outgoing vector. Okay. So, x 1 is entering vector, but all elements in the column 1, this column 1, okay, they are negative. So, we cannot select the outgoing vector. Okay. And hence, the solution of the problem is unbounded. So, we have discussed various cases which occur in the linear programming problems, and we have seen how we can solve them by using the Big M method. we have discussed in detail all the methods. So, that is all in this lecture. Thank you very much for your attention.